Assalamualaikum, and today I would like to show you how to simulate the circuit low pass filter by using multisim. First of all, we need a function generator, and then oscilloscope, then the component of the circuit, which is ground, and the resistor and capacitor. Capacitor can be rotated by clicking this Control R. So the positive goes to resistor, and resistor connect to capacitor. Capacitor connect to common, and ground must have in the circuit. Can copy the ground for the channel A on oscilloscope. We need to put before resistor the negative sign to ground, and the channel B from the capacitor the negative to ground. Then we set up the frequency to 100 Hz, and the amplitude is 2 Vp. Then we can run the simulation. Then double click the oscilloscope. For that, need to change the probe segment color blue or any color. Then run again. Then we will get the waveform. So from the waveform, you can put the scale division. Channel A is the blue one, and the channel B is the red one. So we need to find the V output. This is the cursor. Double click on the red waveform. Put on the highest waveform, and the first cursor put on the lowest, the zero waveform. So from here we can read the V output for this RC circuit. For that, we need to change the resistor value, which is 330 ohm. Then run again. Then run here and pause. The one goes to red highest waveform, the peak of the waveform, and the zero. So from here can determine the V output, which is from the capacitor, from the red waveform, which is now the reading is 2 volt. But now 1.99 volt is, we can consider it is 2 volt. And then to find the phase shift, need to reference the waveform. Different the cursor on the blue red. So we put the scale 1 millisecond. So from the graph, we can determine the delta time is negative 188.6979 microsecond. So delta t we put on the formula, and then we can calculate the phase for the RC low pass filter. So now we can change the frequency to 10 kilohertz. The amplitude is still the same, and then we run it in again. We'll find this output. We pause, then from here we can find the V output for 10 kilohertz, which is the V out is 233.883 millivolt. This is the V output for the capacitor. Then we can find the phase shift, which is delta t is negative 4.764 microsecond. So from the delta t where we get from the output, can put on the formula, and then we can calculate the phase shift. That's all.
Bismillahirrahmanirrahim. Today I will construct a circuit in lab 4, which is RL low pass filter. I will construct the circuit in the multisim. First, we take out all the component from the multisim. Resistor and inductor, function generator, and lastly oscilloscope. After that, I will change all the value of the component. And then I will connect the wire like this. And then I will change this segment to get the difference between channel A and channel B. So like this, and then I will measure the V out and shift of phase angle, which is change the frequency in the function generator 100 Hz, and then we run the circuit and we get like this. We move the cursor to get the V out. Like this, V out is 1.999. 1.999. And shift of phase angle, we take like the cursor 1 and this cursor 2, which is same 0.00 second. So the shift of phase angle we get with frequency times 360 degree times with the difference of time base. So the shift of phase angle is 0. V out AV is V out over V in, which is 0.999, and AVDB is like this formula that we get negative, sorry, we get negative 4.344 times 10 to the power of negative 3, which is negative 0.004. Okay, so we take the highest frequency, which is 10 kilohertz, change the function generator to kilohertz. This is to 10, and then we run the circuit, we get like this. So we change the time base, and then we take the V out, which is 757.285 milli, which is 0.757. So 0.757, and the shift of phase angle is, we take same like the 100 hertz, which is we get 20.1, 20.716 micro, and then we calculate the shift of phase angle. That we get 74.578, and the AV is 0.379. The AVDB is negative 8.439. Okay, that's all from me for lab 4. So thank you.